Alright guys, so we're doing something a little bit fun today. What we're going to try and do is to get the villagers, when the player walks past, to basically just look at you. This is a technique called procedural animation, where you don't actually design an animation for the character, but instead you try to... I'll give you an example of this actually. The animation comes from interaction with the actual world. So you can see, if we jump up, you can do it, mate. Come on. There we go. You can see that his legs, his feet are kind of offset. This is procedural. We haven't actually designed this animation. It just runs some traces. It says, okay, there's a rock here. Let's lift the leg up a little bit. And so we can do the same for villagers. And yeah, to try and make them look at us. This is completely and utterly unprepared, so it could go horribly wrong. But let's have at it. So as you can see here, we have our control rig, which is a place, a file in Unreal where you can do procedural animation. We have our little focus point here. And you can see that our man looks at it as we move it around. His body turns. In fact, we can adjust that a little bit. We probably want his body to turn a little bit more than that. But yeah, he follows it around, right? And so what we basically want to do is to put the player in this position, or to tell the villager, hey, the player's here, look at him, follow the pretty birdie. So let's quickly do some adjustments here. Let's turn the weight up a little bit for these. Let's try 0.4 here. That's 1. Let's try 0.8 here. See what that looks like. There you go, a little bit more body movement there, as you can see. It looks a bit better. All right, happy with that. So, plan, I think, for today, what we're going to try and do, the first thing we need to do is detect when the player is, let's say, close, right? That's going to be the first step. So the player's close to you, get ready. Detect. Second thing is the player in, let's say, look at range. And what I mean by this is you basically don't want that to happen. So I could prevent that from happening altogether by, setting some clamps and making sure that this point never goes beyond a certain coordinate. But yes, you certainly don't want the village to turn owl style, exorcist style, all the way around. That's a bit silly, right? There may be times when that will work, when it will look okay, but for the most part, I think we can probably say that our range should be about here-ish, maybe, something like that. So we're going to basically set up a cone like this, and if you're inside the cone, if the player is inside the cone, then sure, go and look. Right, and so at this point, is the player in the orange? If they are, look. Otherwise, look forward. Right. And I think as an additional bonus, what we're going to try and do as well is add a small delay when in look at range, right? Because we don't want to snap and very quickly, there you are, and we wouldn't want to be like, oh, you're there, I'll just casually turn my head and have a look. We shouldn't need to worry about the up and down VX, because your player is usually the same size. Fortunately, although if you do get a big ogre, then you might get a bit of that, but that will come later. All right, so step one, and before I get into this, and by the way, with this particular video, feel free to skip any parts, right? I'm basically designing the video in the way that I would like to watch it, to be informative, to kind of describe a little bit how the engine works, how game development works. But if you're not interested in this particular part, then feel free to go to the next timestamp. So in Unreal, we have everything in computer science is basically an object, at least in most languages that you use. They are all some kind of objects. Today, I think we're just going to call them entities. So everything in the game will be, every type of class, we'll call them an entity. And I call them an entity because they live and they die. So it just seems like the most intuitive term to use. So in Unreal, we have one entity that lives from the moment you start the game until the moment you uninstall it because you're sick of all the bugs. And this is called game instance. And this holds basically data that persists across all your saves, across all your levels. So your save games or references to your save games will be there. Your game settings will be there. What happens before you click load game? This is all happening in game instance, right? So this is the big daddy of all of them. And below that we have two, a very happy marriage. One at the top we call game mode. Game mode. As you can see, I'm seriously regretting using paint for this. Anyway, game mode, and then game state. And you kind of get an idea about what you should use each of these entities for. I won't go into too much detail because it's not really too important. But what you really need to know is that when the level loads, game mode loads, game mode starts, right? And its little sun game state will also load at the same time, just after. Below that, we have, let's use another color. We have, because it starts just a little bit after, it ends just a little bit before. This is the player controller. Also in orange because of reasons. Which is kind of like, you can think of it as the brain for your character. Like your character, the actual physical entity of your character, the body, and all the various components that you have on that body can live and die. You can die and that body will be destroyed by the game and then it'll be respawned, but your player controller will continue to live throughout. So this kind of lives forever. And then underneath that you have all of your little characters and all the other little objects that you have in your game. What should we call those? Let's just call these, we'll call them game actors. Yeah, so things like your characters, things like buildings, things like, in our game, resources, guns, weapons, all that kind of stuff. These are all little game actors. And there are just thousands of these that get spawned and despawned throughout the game. And so in order to achieve number one here, detect when the player is close, what we're going to do, we're going to use game mode for this, because game mode already has a bunch of data storages for what characters exist in the game, and so it just makes sense to use that because you already have those characters. So we're basically going to filter through the villagers that we have. We're going to say, where are the players? Let's do a distance check to see where those players are, and if they get within a certain range, then we'll tell the villager, hey, you've got a player close, start doing some checks. This is better than having the villagers do it all the time, because the villagers could be, 20, 30, 40 villagers. And if you're getting each one of those to do checks every single tick, 60 times a second, then it's not very performant. And so we're going to do it just in one place. In game mode, there's only one instance of this entity, and so that's where it's going to happen. Okay, so this is game mode here. You can see all of our lovely functions doing different things. This is also where we spawn enemies, spawn villagers, spawn the player, respawn the player. Got some camera shake in here. A bunch of cool stuff. We're going to be focusing on tick. Tick is a function that runs every tick, every frame. And obviously we have this in modern game development. We have this because different computers have different frame rates, and so you kind of need this input. So delta seconds is usually 0.016, I think, which equates to 1 second, or 1 divided by 60, because that's the ideal frame rate you want. But of course, it fluctuates over the game time, and so this number will also fluctuate. So every time this function is called, it says, all right, how many frames are you getting at the moment? And then it translates to delta seconds. So what we're going to do is, we're using perforce, by the way, so what we check out. We're going to iterate over our villagers. So let's do that. We don't need to check, by the way, if this container is empty. So this is all of our villagers. As soon as a villager logs in, or a villager controller logs in, it says, hey, I'm in the game, game mode, save me. And it saves a reference to that particular villager. And then we also want to check, we want to iterate over the players. In fact, I believe, yeah, so these are the controllers. So the first thing we want to do is we want to see, does this particular controller, in fact, I'm going to change this to be more obvious, controller, call it P controller. So we want to see if the controller is controlling something. As I said before, there are bodies that exist and there's the brains that exist. So we're getting the brains. We want to say, hey brain, do you have a body? So let's do that. So this, what we're doing here, you could do this. And this is basically a check to see, does this thing exist? Is there a reference to this thing? If it's a null pointer, then there is no reference to it, doesn't exist. However, in this game, it's not enough to do that, especially on tick, because if a character dies, if a body dies, is destroyed by the game, it is not immediately set to a null pointer. It takes a bit of time to destroy it, basically. And so we have another little function we can use, and this took us a long time to find, believe it or not, which is the isValid. And that checks, is it a null pointer, is there a reference to it, and if there is a reference to it, is it in the process of being destroyed? It's just an extra layer of security, because if you don't do that, and it is being destroyed, then the game can crash and people complain. So, all right, now we have pawns. So we know for a fact that this brain has a pawn, so now we do a little distance check. So what we can do here, all right, so there's a function we can use. Which way should we do this? I wonder if, let me just check this. Yeah, you can get squared distance, brilliant. So you can get distance, you can get squared distance. The way distance works, when you get distance between two vectors, essentially, let me go to paint. Okay, so the way distance works, let's say you have one person body here, and you have one body here, and we're looking from the bird's eye, obviously. The position in space is obviously represented by coordinates, x, y, and z of some kind, and then also we have x, y, and z here. These are called vectors. Anything, you can have two-dimensional vector, three-dimensional vector, 3D game, so we're using three-dimensional vectors. So basically what you have to do to get the distance is you have to subtract one from the other, and then you square that number. And in fact, sorry, this is actually what I'm describing is not necessary just for distance. This is if you want to get the length or the magnitude of a particular vector, or of the difference between two vectors. What you have to do is take the vector, square it, and then square root it. I use square root, I'll just do that. Right, that's the order of operation. The squaring is not particularly expensive. Square roots is more expensive. And so the reason you square root these things, this is basically the same as getting an absolute number, right? So if you want to say 6 take away 5 is 1, got 5 take away 6, 5 take away 6 is minus 1, right? Is minus 1. Minus 1. If you are not interested in whether this number is positive or negative, you can get an absolute, right? And the absolute is basically exactly what we just described. You take the answer, which would be 1 or minus 1, you square it, you square root it, and then you end up with a positive number. It's just a way of not caring about whether something is positive or negative. When you get the length or magnitude, you want that result to always be positive. And this is why you often use this equation. You square it and square root it. However, in the case of distance between two things, the answer is always going to be positive. And so basically what that means is we can do away with the square root part. And we only need to square it. And it basically just means that instead of comparing the answer to, let's say you want to say, all right, is this distance 200 meters away? If you did the distance, vector square root, you'd say, is it less than 200? In the case of eliminating this square root, you have to compare it to that 200 squared, right? Because you're squaring the first one, and so you square the second one. And so that you have to make sure that your comparison is taking into account that you are omitting the square root. Anyway, this is just a slight little performance. You could just do distance, it'll be fine, distance 2. but considering we're doing this every tick, we really want to think a little bit about performance. So we're going to simply do distance, square distance, get square distance 2. And what are we getting square distance to? The villager, right? We're getting between the body, the player. This is the player here. This P controller get pawn, and this is the villager. And let's say something like, let's do 1,000. You'll see. I'll give you an idea of what distance kind of means in this game in a bit. So if this is like that, then we're going to do something. Tell villager. Okay, so we've got our basic implementation here. Let's now go into the villager and write something to prepare the villager for looking at things. So where should we start? Okay, so I think the way I'm going to manage this is we're going to have, in fact, let's make a new category here. In fact, let's cancel that. Do we have something for blue? We don't. Okay. Combat category. Yeah, so I think what I'm going to do is make a new category specifically for procedural animations. Procedural. So we're going to make a container of. Do I need it to be? I think I just be a basic actor, and we'll call these players in range. And so basically what this is, I'm going to use the Pythonic term, a list. You can think of this as basically just being a list of references to players that are in range. So what we can do here, maybe we can do a quick check. Where can we do that? All right, I'll think about that later. Basically, we want to make sure that this is updated so that if we send from game mode, if we send the villager a player and give them an extra player to, if they get out of range, we also want to make sure that we update that. I'll think about that a bit later. So what we can do here is we have a reference to villager. So we'll say players in range, and then we can add them. Add the pawn. This part here, right? And this is, as I said before, this is the player. And so the villager is just going to be doing a simple check every tick to make sure that this array has something in it. So it's called, what's it called? Players in range. And this is just a check to say, is this empty or not? If it's empty, don't do anything. If it's got something in it, then let's do something. So we'll iterate over it. Now, question here is, we have multiple potentially players. How do we decide which one we want to look at? I guess it makes most sense to look at the closest one. Although, in theory, if you have little players doing dances, and moving back and forward just to fuck with the villager, then they could just keep looking at you. But that's an edge case, and if you want to go and do that, go ahead, make the villager look stupid. So let's get the closest one. So firstly, we'll see if it's more than one. So if there's only one, we don't need to worry about looping through them. If there is just one, let's say if that is one, then we will engage look at. Otherwise, we will loop through them. And by the way, just in case anyone's interested, we use this little ampersand because it passes in a reference. In this case, actually, we probably don't need to because they're just pointers. I'll do it anyway, just out of habit. But if you're passing in, if you're looping through big objects, you don't want to copy those objects every single time. So this is just a way of, again, having more control over performance, making the game generally more performant. Players in range. We want to again get the closest to, yeah, I've just realized I made a mistake here. As I said before, I need to square that as well because we're getting the squared distance. So yeah, so let's get another squared distance check. So if, all right, and for this, I guess what we need is to have a tracker. Float distance check, call that 0. And then we also want to have an object check, closest actor. In fact, we'll make this negative because the first loop, we want to know if it's the first iteration. And there is other way to manage this. You could have, there's a different way of doing a for loop. Anyway, not important. No one cares about that. So yeah, if this check is less than 1, float, then we will just initialize, get the distance. If we can do squared distance here. So get distance 2. So because now we're in the villager class, essentially this is the villager getting distance 2. Player is the distance to check. And then we want to initialize the closest actor. Right, and so the first time we're looping through, the first item on that list, the first player on that list that we talked about, we're just going to automatically initialize these variables, and then everything after we're going to compare. Closest actor. What happens when you try and code and talk? Else. So if it's not the first iteration, then we're going to do a comparison. So if, yeah, let's, yeah, we want squared distance, don't we? Yeah. Okay, so if squared distance 2 is, so if the new distance is less than the distance that we've had before, then it's closer. We want to reset these variables. If it's further away, we don't care. We're just going to ignore it. Layer. And then let's get this in here. I'm just going to repeat this. In fact, let's cut down on the overhead a little bit. We only want to do that operation once. Let's just do new distance. And then we can just pass that in. Then we're not doing that operation twice. There we go. And that should do it. And then we get to the end of this loop here. After the loop, and then we say if we do have some kind of valid player, right? Again, we're making sure, let's do an is valid as well to make sure it's not about to die. We want player, we want closest actor. This just makes sure that for whatever reason, if it doesn't make it through this loop, if it gets cancelled midway through, or for some reason it doesn't make it through this loop, we want to check if it is this null pointer. We can't do anything if there's no reference to any kind of actor. So if it is, if we did find some kind of close actor, then engage lookout. Okay, so we've done already now 1, we've done 2. We kind of haven't done 2 actually. There's more we need to do here. Okay, so actually, no, we're not going to be doing this. We need to do part 2 on the list, which is the player in the lookout range, right? So we talked before about if we want, so let's say this is our situation, right? And our villager, do I have an arrow anywhere? No, like these arrows. If our villager is looking this way, right? And this is our player here. P for player. P for pink. Then we want to basically look at this cone, evaluate this cone. Can you do any cool stuff with... Can't do any cool stuff in general. Hey, let's do this cool stuff. So if we want to basically draw this cone like this, and say, are you inside this cone, right? In this case, he's not, so it's going to fail, right? And so this would return true. Any more cool stuff? Let's use that one. Holy shit, that's big. Or if it's not, it's going to return false, right? That's basically what we're going to test this cone now. And the way we do that is using the dot product. The dot product, I'm not going to go into too much detail, but long story short, if you have two directional vectors, let's say like that and like that. So this is, for example, your look at rotation, your look at direction, sorry, this way. You're looking this way. And then we have another player here. So we have another directional vector, right, which is this way. You compare these two to look at how close they are together, basically. And so if we go to blue now, you can divide this into quadrants. If this line here, or if these two vectors are the same, if it's like 12 o'clock, for example, that would return 1. If it is 3 o'clock or 6 o'clock, that would return 0. 3 o'clock or 9 o'clock returns 0. If it's 6 o'clock, it returns -1, right? So you can move this particular, or you can move, let's say, the character all the way around here, and it would be returning different numbers, right? 1 down to 0, -1, back to 0 to 1. And there is a way to turn this into an angle if you want. If you can turn this to 45 degrees, 90 degrees, 180, and then it goes negative on the left side. But we don't really need that much precision. You have to use some trigonometry, and there's a little bit more performance overhead. So we only use that if it's absolutely necessary. In this case, we just kind of want an approximate cone. We're not really too worried about precision. And so I think what we'll do is we're just going to find a good cone. Do we have we do still have this open. So let's go and do a little bird's eye and see what our cone might look like. So how does this look? If he's walking along, is that too much? A little bit too much, maybe? I think we just want to do about here, right? And so that's approximately, I'm going to say about 0.5. So let's aim for, yeah, about a cone of 0.5. And bear in mind that this is obviously, this side would be 0.5, this side would be 0.5. It's not positive, negative, it's exactly the same, right? So 0.5 is here, more or less. It's not exactly halfway down, but again, we don't really need too much precision, and if it looks terrible, we can always adjust. So, dot product time. Right. Okay, so we need our two vectors for comparison. The first vector we need is quite easy to get, and it's going to be where the forward vector of the villager, in other words, where is the villager looking? So we'll call this vil forward. And this is very simply, Unreal has a built-in vector, get actor forward vector. Easy. Next one, slightly more complicated. We want to get this, basically this vector here, right? So we have our player here, and we want to basically look at the difference between these two and find the direction looking from the villager towards the player. To do that, you take the coordinates, or the location vector of the player, the location of the villager, and you find the difference. It's a little bit counterintuitive because the way it works when you're getting directional vectors is you want to get the target and you want to take it away from the subject, right? So the target would be what you're looking at, in this case the player, and the subject is who we're working with, which is the villager. So it's in a bit of a weird order. So target first. We want to get what we're going to call this look at direction. So the target is the closest actor, position, or location. And then we want to take away from that the location of the subject, which is me, the villager, which is what we're working on. Villager, up here, get actor location. Now, this is not quite good enough because one thing that's useful to do, not essential in every case, in this case, it just makes life a whole lot easier. If these two vectors, at least for this dot product to work, at least one of them has to be normalized. A normalized vector basically means that it has the length or the magnitude of 1. So the let's say we have, well, if you look at this vector here, this directional vector, this distance between one point and another point, actually technically it's all the way up to here, might be 200, 300, 400, whatever. The normalization basically reduces it to 1, a length of 1. And so we do that for both cases. Fortunately, we already have 1. The forward vector is automatically normalized, so we don't need to do anything there. However, to make life easier, we're going to normalize this one as well. Get safe normal. Get safe normal basically checks that you're not, one of these vectors here is not 0. If you divide 0 by anything, the world ends. And so this is basically Unreal's way of saying, hey, make sure that it's not 0. And it will just return something weird like a 0 or not a number or something like that. All right, so we have our two vectors. Now let's do a little dot product. So as we said before, doesn't matter which order you do the dot product in. Dot product with look at direction. We basically want to make sure that that is greater than 0.5, right? Because we want it to be between 0.5 and 1. That's what represents our code. Now, in this point, we engage. Look at. All right, so we're pretty much there. Actually, yeah, this check also needs to go in here, doesn't it? So we need to check if it's in a cone. So finally, this is going to be the first element, first item. Okay, so now we need to start putting it in game. So in order to get this working in Engine, what we need to do is make some variables, and in fact we need to make them in C++. So we'll do this, firstly we need to expose it, make sure that the engine can see it. So to do that we'll do blueprint, excuse me, read only. Do we want to change it? Do we want to edit it? No, that's fine. And this is going to be is, let's say, look at engaged. And that will be false by default. And then we want another one, which is the direction, the location. So where are you going to be looking? Where's the villager going to be looking? So this will be a position in space, and we call it look at location. All right, so let's restart the engine. Okay, so we're back in Engine. So the way procedural animation works in Engine is always through the animation blueprint. We're going to have the villager, don't we? Animation blueprint. Yeah, so anything really animation-wise, at least in a game of reasonable size, is always going to be filtered through, excuse me, the animation blueprint. So let's go to here. So we have already some control rigs that exist. Ah, we have this already on. Okay, great. All right, so this is the flow of animation through the engine, and this is basically what outputs at the end. There's too much to explain here. We have blinks going on. We have, why do I have 2 blinks? I feel like that shouldn't be the case. Blinks, and anyway, whatever. So this is our control rig that we looked at here, this one here, and it's saying, all right, guys, if the should follow. if this is true, then you need to firstly set the transform of this lookat location here. So this is the, if you remember, we fed this variable here, lookat location. We're going to update it in code. And this is basically saying, all right, we've received that location. Now move this little square to that location. And then this stuff, just make sure the body follows as we looked at before. So these are the two variables that we've just put in, and now we need to make sure that they're being set correctly. So here, let's see if we can find look at, no, what was it called? It's called procedural gaze on, I don't like the name of that. Maybe we can just find the references. Set. There we go. All right, so this is where it's being set. Going to get rid of that. And then move this and get our look at location. That's going to be here. Oops, no, we don't look at location yet. Actually, we do want, we'll put that here. And then we want to get our look at engaged. Yeah. All right. And let's just call this a little comment here. We'll call this procedural. Procedural animations. Nice little category. All right, that's that done. And that should basically work now. So once that's engaged, once this has been turned on, then this controller gets activated, and then it starts doing the magic here, right? It starts setting this location, and it'll start looking. So last thing we need to do is to go back into code and make sure that we're actually setting these variables. So let's go back into our villager. And so engage lookat basically means engage lookat engaged. It's going to be true. And then we also need to, in fact, let's do this just a little bit before. Not that it makes a big difference. Look, what was it called? Lookat location. I feel like that's a bad term to use. Oh well. Is going to be the location of the player in range. This one here, right? The location of where the player is. And same here. And this engage. But in this case, it's going to be the player. No, closest actor. So one problem you might have noticed here is that as it stands, we are going to have our exorcist style, right? Because we're not turning this off at any point in code. So the first thing to do is that if this is not true, so if we don't have, if that list is going to be empty, then we want to make sure that he's looking forward, right? And in fact, maybe it's going to make sense to have a little function to make him look forward, because we're going to be repeating this quite a lot. But now let's not. We can always refactor as we work through it. So first thing we want to check is, in fact, we can probably do that here. Are you already looking forward? So I think we want to reset. Yeah, okay. So we want to see, is this open? Is this on? Let's look at engaged. If it is, then we'll turn it off immediately. And we'll also reset this look at location. And then we're going to have a little fixed point in space, which is basically what we're going to do is we're going to project so we've got the forward vector here. If we just set it to the get forward vector, it's a normalized vector, so basically it's going to be in front of his nose. So we want to project it forward a little bit to be, you know, just a little bit in space, forward in space, so he's not constantly trying to stare at his nose. So we'll do that here. It's going to be the Actor location plus get actor forward vector, and then we'll project it, let's say, I don't know, 500 into space. So this is just fixing the location in front of you. If this is off, it won't matter anyway, but it's just nice to have that working. One problem we're going to encounter as we start looking at this working in Engine is that his head at the moment is going to snap from one location to another. We want to ease it. We talked before about a bonus, add a small delay. We also want to lerp between look at values. Which basically just means that you want to slowly move or more slowly move instead of snapping from one location to another. If he does move his head from the center to wherever the player is, you don't want it to be immediate. It's going to look stupid. So we'll see that looking stupid first, and then we'll come back and edit. All right, so here already, basically this is checking whether if we look at our location, our operations here, is the player at look at range? If they are look, so we've done that here. That's if they are look, but we also want to include otherwise look forward, right? So that's the otherwise is going to be here, and then we will do exactly the same as we did here. We don't need to function this, it's 2 lines. It's fine to repeat 2 lines. And this is going to be again phase and range. And then exactly the same here. So we need to have 2 of them actually. One here in case for whatever reason you can't find an actor. Why you do this to me? Okay, is that right? Application. Yes, yes, yes. And then it's the same here. There's just a few situations where we might end up with. So this one is not in the cone. This one also is not in the cone. This one, for whatever reason, we couldn't find a valid player, in this little list. And this one is we don't have any players in our list, so we're going to look away. So these are just basically covering all of our otherwise look forward sections. And yeah, and this is where our little lerps are going to go as well eventually. Are we missing anything here? I think we are not. Probably. So, all right, so let's recompile and see if it works. All right, so let's see if they are snapping their heads Exorcist style. They are. Hey, look, they're looking. How's it going, buddy? Hey, how cool is this? And look, and you can see when you go out of range, they snap them forward again. Right? Brilliant. Brilliant. First time. Wow. Very rarely happens. Hey, walk towards me and look at me. This is awesome. All right, great. So the last thing to do is we're going to add a little bit of a delay. And I think first things first, we're going to, yeah, just try and add a little bit of a lerp to these. Yeah, linear interpolation lerp is a super common aspect of game development, and as I said before, it just basically eases the transition between 2 different values. So for example, going from 0 to 1. So for example, fading out, right? When you're fading, a screen fades out. Essentially what you're doing, say the screen wants to go black, for example, that's the fade out you're going for. You basically have a black background, which is, say, value 0, and then you have your current background, which is value 1. You don't want to go immediately from 0 to 1 or from 1 to 0. You want to slowly go between them. That's also an interpolation. Linear just does it do it the same amount of steps, so like over 1 second does it happen at the same rate. You can have other types of interpolation, which has different kind of curves. Anyway, basically it just goes slowly between 2 different points, 2 different values. In this case, we're going from 2 different vectors. So, what we're gonna do is, I think we can literally just plug that into here. Let's try this. So where is our interp? I think it is in fmath library. vinterp. Yep, so we have a vinterp here, which interpolates between two vectors. We're going to do constant, because I think you're really going to notice much of a difference if you have interp speed here. Maybe we can play around with that value. All right, so interp, so we're starting from our current lookat location, and then we're going to interpolate to our next location. Interp to, what's your issue? Far? Sure. Yes, we also need, okay, so in this function, we need to include delta time, which is the frames per second. And we also need the rate at which we want to interpolate. This value basically is a fraction of a second, right? So if you put 1 divided by 1, 1 divided by 1 second is 1. If you have 2, 2 divided by 1 is 0.5, so I'll do it at half. It'll take half a second to interpolate. I think we do it quite quickly. Let's try 8 here and see what it looks like. I also would quite like to play around with this value so that you're looking at different rates. So basically, I'm just going to add this to all of our changes of the lookat location, and that includes when we go back to our standard looking forward as well. So let me just do that. Okay, so I think that's everything. So let's boot up and see if the snapping has disappeared. Okay, so I think that's everything. So let's open this back up and see if they have stopped snapping their heads. Oh god, let's do it without the snow. All right, lovely. Good. A little bit of snapping going on. All right, let's figure out why. What have we missed? Okay, so after some debugging and getting distracted and dealing with other issues and then coming back to it, we have a working system. So let me explain what changes we've made. So back in game mode, a few mistakes I was making before. One was constantly adding to that player, of this players in range list that we had. I didn't have a check before to make sure that you're only adding if you haven't already sent the player. So it's like, hey villager, have already told you about this player that's in range. If I haven't told you, here he is. If I have, then forget about it. And also we have a little extra line here, which just makes sure that when they go out of range, we check to see if they have, this villager has a reference. If they do have a reference, then we delete it. So it's basically updating this player's in range variable to make sure that you only ever have references to those players who are here within this little range here, within 1,000 Unreal units of you. And on the villager side, so the reason it was snapping before is because when I was doing this interpolation, let's take this part here. When I was doing this interpolation, what I was trying to do initially was to check to see if the lookat location, so the location of this little, oh bollocks, let me load this back up again. Yep, so this little lookat nodule, not nodule, is that a word? We'll go with it. Is to make sure this lookat nodule. So here we're checking, is this little lookat nodule, I'm running with that word now, is it in the same location as the player that you're supposed to be looking at? And I was using the dot product to try and find that out, but I wasn't using normalized vectors, so it was kind of, anyway, bad maths. And what I kind of decided to go with in the end, so I could at this point here, I could check to see, to compare the location of this and the location of this. Why are we here now? Bum. But I kind of figured that if we're doing the dot product every tick on here, it's not really any more performance. So we might as well just, if you are outside of that cone, so this is if you're in the cone, if you're outside of the cone and, you're using this control rig here, then just consistently move this nodule to in front of you, to like this this space that's projected in front of you. And then naturally when game mode tells you, all right, this player has left this particular radius, then it will snap back anyway, and it will turn off here. At this point, it will turn off the control rig, and then you disengage, this procedural animation. So I just figured it was more performant to do it that way. You could do a check here, and I think I do a check at this point here to check whether the lookout location and the location of the player is the same, and if it's not the same, then lerp to that location. If it is the same, then let's go away from the control rig, this procedural animation. So that was that. There's a few other little mistakes that I'm sure people were shouting at. There was a minus somewhere. I think it was here. Distance check -0 instead of less than 0. Just a multitask error. And maybe one or two other things in here as well. But yeah, so the only thing we really changed was just to, check this cone. If you're in the cone, then we're going to lerp, and as soon as you leave the cone, then this is the state, or this is the part of code that makes the head move back without snapping to interpolate back to a space in front of you. So from this lookout location where the player was to some space in front of you. The other thing I added, so initially I did have a little check here to see, are you within this range, but also are you too close, because we didn't want exorcist. But this was just a lazy way because I didn't want to add clamps. I couldn't be bothered, but I added clamps now. And so here, before this vector gets fed in to, these are the aims, this is the part that kind of moves the body up and down. I clamp it, and as you can see here, I'm just clamping these values, only the Y and Z, because the X is going this way to this way. I don't really want to clamp that, doesn't matter too much. And as you can see now, if we move, it stops at about this place here, right? So you can move it back. This lookout location could be all the way back here, but he's never going to turn around because we're clamping those values. And likewise, he can only look so far up and down as well. That's the Z, as you can see here. And the way you can do this, if you want to actually try and do this yourself, I just made a function. I plugged the vector into here, and then I find that the values here, how can we see them? The values here are not really that reliable, and so it's kind of a little bit of trial and error. You move it up, you change the minimum and the maximum until you get to a state that you're kind of happy with, and I think that looks quite good. Yeah. So let's have a look. I need to plug this in, bosh, and plug this in, and then we should be good. Where are you, villagers? There you are. So as you can see, he's looking at me, and when I go out of range, it doesn't snap back, it lerps back. Test over here. Amigo. Oh, down. Hey. There we go. So I think that's looking quite good now. I'm quite happy with that. There are some things we can do. If you're too close, he looks down for some reason. So we can try and adjust that. I think it's because the location of the player is in the center, is basically in your pelvis. And so he's actually just looking at your penis, which is by design. I want to make some perverted villagers. But yeah, we can fix that later down the line. But I think that looks quite good. The only thing missing that we could do, because this is a multiplayer game, and so we need this to work on the server and the client. If you want to do that, you just need to make sure that the variables that are getting fed into the animation blueprint, you're going to navigate somewhere, aren't you? Don't navigate. Cancel. Damn it. Don't respond to voice. Make sure that these two variables are A, replicated, and B, you make sure that when you do change them, you change them on the server, not the client, which we kind of do here. So that's it. All right, that's it. We're going to make something else, some other stuff in the future, but for now, See you later.